Jai Hind to all. My name is Dr. Divya Sharma, Assistant Professor in Ajay Kumar Garg Engineering College. Now today's video lecture is on VLSI and this topic is CMOS and it is taken from VLSI Design subject and its code is BEC 701. Now in this lecture we have to study CMOS, its stick diagram and layout. Now first we will discuss CMOS. So how to design CMOS? So as you all know, in CMOS, this is a PMOS and this is NMOS. So there is a combination of PMOS and NMOS. PMOS is in the pull-up network and NMOS is in the pull-down network. Now here first we have to discuss what do you mean by CMOS. So what is the full form of CMOS? That is complementary metal oxide semiconductor logic using both PMOS and NMOS, and both are in complementary arrangement. So we can see this structure of the CMOS where PMOS is in the pull-up network and NMOS is in the pull-down network. Now PMOS connects the output to VDD when logic high is needed, and here in the case of NMOS that connects output to ground when logic low is needed. Now here, what are the advantages of this CMOS? So very low static power consumption. In ideal case, current flows only during switching, and second is high noise margin. Third is scales well with Moore's law. Now if we take an example of CMOS, this is an example of CMOS inverter. If we are giving here input 0, this is PMOS, this is NMOS. So PMOS in the pull-up network, NMOS is in the pull-down network. PMOS is connected to VDD, NMOS is connected to ground. And from here, we have to take the output. So we are giving input from here and input is connected to this PMOS and NMOS both. Now, if PMOS, if input is 0, it means PMOS is on and NMOS is off. And off means open circuit and on means short circuit. If it is short, it means output is connected to VDD. Here it is open. So output is connected to VDD means if we are giving input 0, then output is equal to 1. And in the case when input is 0, then output is equal to 1. And inverter, you all know, A is equal to A bar. So input is equal to 0, then output should be equal to 1. So here we have to verify it also. Now if we are taking input is 1, if input is 1, it means NMOS is on here and PMOS is off here. And off means it is open circuit. So you can say output is connected to ground. It means when input is 1, then output is equal to 0. So this principle we can use in NAND and NOR, XOR. These are the gates. So we can use here also. So we will discuss later. So if we have to design an NAND gate using CMOS, and if we have to design NOR gate using CMOS, if we are taking the case of NAND gate, so these are NMOS, pull down network is NMOS and pull up network is PMOS. So NAND means Y is equal to A into B ka whole bar. So A and B, two inputs are there. So here in the case of NMOS, A and B are connected in parallel, and if they are connected, A and B inputs are connected in parallel. So in the case of PMOS, A and B are connected in series here in the case of NMOS, and A and B are connected in parallel in the case of PMOS. When we are designing a NAND gate, so we have to consider if we are implementing it with two inputs, then A and B. So A and B are connected in series in the case of NMOS, and we are getting output here Y is equal to A dot B bar. And these PMOS is connected to VDD and A and B are connected here in series. Here we have to connect it in the parallel. Now here we are taking the case of NOR gate. So NOR gate means Y is equal to A plus B ka whole bar. It means two inputs are there. So it means if two inputs are required here, so A and B, in the case of NOR gate, A and B are connected in parallel in the NMOS, and in the case of PMOS, A and B are connected in series. So this is the designing of NOR gate using CMOS. Now these are the advantages of CMOS logic: low power consumption, high packaging density, low static power dissipation, high input impedance, lower heat generation, high noise immunity. So these are the advantages of CMOS logic. Now we have to proceed for the stick diagram. Stick diagram represent the layer information using simple diagrams, and layer information is conveyed through color codes. So we will discuss color codes later. Now here stick diagram also act as an interface between symbolic circuit and the actual layout. Now these are the general rules for this when we are designing stick diagram. So we have to follow these rules. Layer connectivity. It means two or more sticks of same layer crossing or touching each other, that indicates an electrical connection. Now second is layer isolation. It means sticks of different layers crosses or touches do not form an electrical connection unless an contact is explicitly shown. Now third is transistors. A transistor is formed when a polysilicon stick crosses the diffusion stick, either N-type or P-type. Now contacts, so a connection between two different conducting layers, that example we can take metal to diffusion, that is explicitly indicated by a filled square or circle. Now crossovers, so different conducting layers, example metal, polysilicon, can crosses over each other without making an electrical connection, separated by an insulator. So these are the general rules. Now CMOS specific rules. So there is a demarcation line. So when we have to separate NMOS and PMOS, so we have to draw a demarcation line in between PMOS and NMOS. Now power and ground rails. So power is represented by VDD and VSS. Ground is represented by VSS. Now P diffusion and N diffusion. So to avoid shorts, P type diffusion for PMOS and type diffusion for NMOS, that crosses or touch each other. Now substrate contacts, a substrate contact or tap must be explicitly included for both N well for PMOS and P substrate for NMOS. A cross mark is often used to denote this. Now series and parallel transistor. So we have to, if we have to do a series, then draw in a zigzag pattern. If we have to draw a parallel transistor, then we have to arrange it in a U shape. Now common color codes. So and for an N diffusion, we have to use the green color. For P diffusion, we have to use the yellow or brown color. Now polysilicons are represented by red color and metal lines are represented by blue color. So these are the colors we have to use when we are drawing a stick diagram of CMOS inverter or CMOS NAND using CMOS, NOR using CMOS. So we have to use this color coding while implementing the stick diagrams of any design. So we can see metal line is represented by blue color like this, polysilicon line straight line like red color, and diffusion is of green color, pure diffusion is of yellow color or brown color. Now rule number 1, we have to follow some rules when we are designing stick diagrams. So rule number 1, when two or more sticks of same type crosses or touches each other, that represent electrical contacts. You can see two metal lines are there, so you can see the representation, and if two polysilicon lines are there, so see the representation. Now rule number 2, when two or more sticks of different type crosses or touch each other, there is no electrical contact. If we have a electrical contact, means if you have a requirement of electrical contact, so we have to show the connectivity explicitly. Now here, see this is polysilicon line, this is metal line. If we have to show a contact, so we have to draw it like this. Now here metal line, diffusion line, if we have to show a contact, so we have to do it this explicitly. Now rule number 3, we have a polysilicon line crosses diffusion, it represents a transistor. It means we have to note down if a contact is shown, then it is not a transistor. You can see this is a polysilicon line, this is N diffusion line. So N diffusion is represented by green color. So here now polysilicon line is here, P diffusion is represented by yellow color or brown color. If we have to show a contact, so we have to show a contact like this, but this is not shown as a transistor. Here in this case, if we have to show a NMOS transistor, so we have to represent like this, and if we have to show a PMOS, then we have to represent like this. But if we are representing here contact in between these two lines, then you cannot say this is a transistor. Now fourth is rule number 4, in a CMOS, a demarcation line is drawn to avoid touching of PMOS and with NMOS. So this is a PMOS, means transistor PMOS, this is NMOS. We have to draw a demarcation line in between PMOS and NMOS like this in a brown color. Now let us take an example of CMOS inverter. So this is PMOS, this is NMOS, this is input, this is output, this is VDD, this is ground. As you all know how to design CMOS. Now here, this is a circuit diagram. We have to draw its stick diagram. So VDD, first we have to draw VDD. This is VDD. This is of blue color, means VDD is metal line. This is also a metal line, ground. So first we have to draw VDD, then we have to draw a ground. Both are of blue color and these show a metal line. Now we have a PMOS. PMOS is represented yellow color, or you can say brown color. Now here this is NMOS. NMOS is represented by green color. Now there is a contact in between VDD and this here this is a transistor PMOS. This is a transistor NMOS. So we can, through this contact, we can show here this PMOS is connected to VDD, and this PMOS is connected to this output. You can connect here contact, and this NMOS is connected to ground. We can connect here contact, and this NMOS is connected to the output. We can connect a contact, and this is your output, and output is represented by a metal line. So metal line is of blue color. Now here two input X is there, and X is connected to this PMOS and NMOS. So input is a polysilicon line, so it is of red color. So we have to show it like this, and this is your output. So this is a stick diagram of CMOS inverter. Now CMOS using NAND gate. NAND gate means in case of NMOS, A and B both are connected in series, but in the case of PMOS, these two are connected in the parallel. Now you can see this is a PMOS. So here PMOS, this terminal is connected to VDD. This is source, this is gate, this is drain, and here this is NMOS. So this is drain, this is source. So you should know the source, drain also while you are representing PMOS and NMOS, because it is here we have a requirement when we are doing this stick diagram. So first here for that circuit we have to draw VDD and then ground here in metal line, that is of blue color. Now next step is we have to show this is PMOS, this is NMOS. PMOS is of yellow color or brown color, and this is NMOS, this is of green color. Now here we can represent drain, source. It ups to you how you can write down. You can write down drain, source here, or you can write down source and drain here. It up to you. You can write down drain, source, and gate is here. This is polysilicon line. Now in the next step, there is an same VDD and ground is here. Polysilicon line is there of red color. Now here this is PMOS, this is NMOS, and well is here. Now this is the combined structure of this NAND CMOS. Now here this is a circuit, and this circuit we have to denote it. This is source, this is drain, this is drain, this is source. Why it is important? Now we can see this stick diagram, and you can see why it is important to denote it source and drain. Now first we have to draw this VDD and this ground. So here it is a blue color VDD, and it is ground color in ground, and it is of blue color. Now you can draw this line and this line first. Now second step is you have to represent the PMOS. So PMOS is represented by yellow color, and this is NMOS. So NMOS is represented by green color. Now here we can see source and source are connected to VDD. So here you can write down source, drain, drain, source, source, drain, drain, source. Now you have to see source and source of PMOS are connected to this VDD. So this one you can see this is there is a connection in between source to VDD. Now drain and drain, both drains are connected to the output. So both drain you can take a common metal line, and this is connected to the output. Okay. Now here in the case of NMOS, you can see the green line represent the NMOS. Now here you can write down source, drain, source, drain. Now you can see source is connected to ground. So anyone, you can see this source is connected to ground. Now source, this transistor drain is connected to source. So drain is connected to source means here drain and source, and next drain is connected to output. So this drain is connected to this output, and here in between this is PMOS and this is NMOS. So here you can draw a demarcation line, and you can see you can represent here cross, and you can see this is a metal line of blue color, and this represent you ground, and this is a metal lines, or you can say substrate contact, and you can say this is VDD. So this is a stick diagram of this NAND CMOS. Now you can take an example of this where you have 3 inputs are there, and if NAND 3 stick diagram you have to draw. So A, B, C, 3 inputs are there. So 3 inputs are in the case of NMOS, these are connected in series, and PMOS are connected in these 3 inputs are connected in parallel in the case of PMOS. Now we have to draw a stick diagram for this. First we have to draw VDD, then we have to draw ground, then we have to draw a PMOS line. PMOS is of yellow or brown color. Now after that we have to draw a line for NMOS. This is of green color. Now we have to represent source, drain, source, like this. Now we have to see if this one is connected to VDD or this one is connected to output. So we have to see the combination. First we have to write down like this. We have represented source, drain here. So like this we can write down source, drain. Now here drain, source, drain, source, drain, source, like this. And source is connected to ground. Here source is connected to ground, then source is connected to D, then source is connected to D, then drain is connected to source, then like this, and this drain is connected to output. So this drain is connected to this output, like this. Sorry, this is the case. Yes, this one is the case for this one. Now if we are taking a case of PMOS, so here source of all these are connected to this VDD. So you can see these sources are connected to VDD. So we can take a common this metal line in between these two sources, and here is single line for this source, and drain are connected to output. So all these drains are connected to this output. And here you can draw a demarcation line also in between PMOS and NMOS. So this is a stick diagram of this example. Now you can try for the stick diagram for this CMOS NOR gate. Now in the case of NOR gate, NMOS are connected in parallel and PMOS are connected in series. Now again you have to draw a stick diagram for this. So first you have to draw VDD is of green, it is of blue color metal line. Here ground is of blue color metal line. Now after that we have to draw PMOS. PMOS is of yellow color, NMOS is of green color. Now here we have to represent source, drain, gate, like this. So source is connected to VDD. So this source, you can write down source, drain, source, drain. Here also source, drain for this NMOS. Now source is connected to VDD, source is connected to VDD, source is connected to drain, source and drain here, and drain is connected to next source for this PMOS here. Now drain of this transistor is connected to output. So drain is connected to this output. Like this, we can take an example for, we can take a case of NMOS. So here sources are connected to ground, sources are connected to ground, and source is connected to VDD. Here source is connected to VDD, source is connected to, sorry, not VDD, this is drain, source is connected to drain, and both these drains are connected to output. So we can take a common metal line in between drain, and this is connected to output. Now draw here a demarcation line in between PMOS and NMOS. So this is the stick diagram of CMOS NOR gate. Now stick diagram, so there is some limitations. It does not show exact placement of components, transistor sizes, means wire length, wire width, and tub boundaries, and any other lower level details such as parasitics. So here these are the limitations in this stick diagram. So here next we will discuss the layout. So layout is a representation of integrated circuit in terms of planar geometric shapes. So we can read out the rules of this layout. In the next step, we have to follow this. There are two types of design rules, micron rules and lambda rules. We have to follow the lambda rules. Now you can see end diffusion, it is of green color, and we have to draw a stick diagram like this, and we have to draw a layout for this. And in this layout you can see this is the 2 lambda is the width here, and here width of this 2 lambda of this end diffusion, like this. P diffusion is of yellow color, polysilicon is of red color, metal lines are shown by a blue line. Now here we have to draw a mask layout for this stick diagram, and here we have to measure the width also. Now here for end diffusion, here width is 2 lambda. In between end diffusion and P diffusion there is a distance of 2 lambda. Now width of this P diffusion is also 2 lambda. Now if we are taking a distance in P diffusion, a polysilicon is of 1 lambda only in between these two. Now here NMOS and PMOS, there is a difference, distance of 2 lambda. If we are taking a distance on PMOS and metal lines, so we have to take 2 lambda. Width of VDD and ground is of 3 lambda. So this is the description how we can draw a layout. So it is very easy. First we have to draw the circuit, then we have to draw the stick diagram. Already stick diagram is already discussed in the previous slide. Now here, according to the circuit and this stick diagram, we have to draw a layout. Now here VDD, so this is a metal line, so it is of blue color, we have to represent like this, and here its width is 3 lambda. Here it is ground, its width also 3 lambda. Now in this VDD and this PMOS, so this is input, means polysilicon line, it is of red color. Now here is a metal line, you can represent V input. Now here you can see VDD, distance between VDD and this PMOS is 2 lambda, and width of this polysilicon line is 2 lambda. Now here a contact in which is connected to this, which here you can see PMOS is connected to this VDD by this contact, and its width is 2 lambda. Here length and width of this contact is 2 lambda. Now here this PMOS is connected to the output with this contact. Now this is the output which is connected to this metal line. This here is also a contact. So these are metal lines. You can represent it like vertical lines, you can represent by horizontal lines. Now here this is V out. So first we have to draw the VDD. It's write down its width. This is ground, write down its width. This is also 3 lambda. Now PMOS, its polysilicon line width is 2 lambda. In distance between VDD and polysilicon line is 2 lambda. Now here is a metal line, so this metal line is of 3 lambda width. Now like this you can draw the layout for this CMOS inverter. Now second case, you can see this is a NOR case. So in the NOR case, A and B are connected in parallel and A and B are connected in series in the case of PMOS. Now here we have to draw a layout for this. First we have to draw a VDD like this, and we have to draw a layout for ground like this. Now here two inputs are there, it means you have to draw two polysilicon lines, A and B. Now these two polysilicon lines are connected to this output. Here you have to connect a contact. Here you have to connect a contact in between this PMOS and VDD. So this is output. Now here draw a demarcation line. Now this output is connected to this metal line here, this NMOS through this contact. So here A and B are connected in parallel. So draw a layout for this A and B like this, and this is your ground. So like this you can draw a layout for this NOR gate also. Now we can take an example of NAND gate. So in NAND gate, A and B are connected in series, A and B are connected in parallel. So we can take a vice versa for this, for the previous one circuit. Here we can see this is a layout of VDD, it is a layout of ground. Now here A and B are connected in series. So A and B are connected in series, so you can draw a polysilicon line. These two polysilicon lines are parallel to each other, A and B, and these two polysilicon lines are connected to ground through a contact, and these two polysilicon lines, which is a case of NMOS, these are connected to through this contact to this output. Now likewise you can see the case of PMOS. Here A and B are connected in parallel. So A and B polysilicon lines are connected in parallel, means in a U shape, as we have discussed what are the rules we have to follow when A and B inputs are connected in parallel or series. So here these are the polysilicon lines of A and B, and these two PMOS, this one is PMOS, this one is connected to this output through this contact, and these two means PMOS is connected to VDD through these two contacts. So here we are getting the output. Draw a demarcation line in between PMOS and NMOS. So this is the representation of CMOS, NAND and NOR and inverter using CMOS. So we can draw a circuit for NAND, NOR, and we can draw a stick diagram. Then after that we can draw a layout. In layout we have to write down the width also, like here VDD is its width is 3 lambda, its width is 3 lambda. Here polysilicon line, its width is 2 lambda. Here means we have to write down representation, we have to do it in lambdas here also. So for this topic we can refer this Bucknell book. These are the books for the VLSI, and you can refer this topic CMOS, NAND, NOR, stick diagram layout from this book Pakna. Thank you.